Okay, good morning. Thanks for your patience. We're going to just skip the online webcast portion. Hopefully folks can check out the recording later on. So thanks for coming early this morning. This is, I think, something like my 20th Tech Ed worldwide. So it's always great to come to Tech Ed because we get to talk about things that you can go home and use immediately. So this is certainly no exception. This is test automation with Visual Studio 2010. Specifically, we'll be focused on coded UI tests as well as lab management. So certainly there are a lot of other test automation capabilities that have been in Visual Studio for a while. Unit testing, load testing, web tests became web performance tests in this release. It's really a different name for the same thing. But today we're focusing on the new test types in Visual Studio 2010. So my name is Brian Keller. I'm a technical evangelist for Visual Studio Application Lifecycle Management, which really means it's a fancy word for everything you do across your entire team to build and support great software. So it's no longer just focused on making developers really productive. Visual Studio is really trying to appeal to the entire team. So hopefully you got a chance to check out some of what's coming in vNext around bringing stakeholders into the operations, bringing operations and support personnel into the development team so that when you find a bug, you can file that right against the development team, and they have all that rich, actionable data. If you came to my session yesterday, I showed how in the 2010 release, we also included manual testers in that life cycle as well, so that as manual testers are going out and running their tests, we can help make them more productive, not only running their tests, but when they find issues and file those back to the development team, you have everything at your fingertips to say, okay, I know exactly what the tester did, and then I have some clues about their environment and maybe the stack trace from that test run to tell me how to fix that. So today we'll be focused on once you have started to evolve your manual tests and you want to start turning those into some automated tests, then how can you do that with this release? So I work in Redmond. I've been on Visual Studio for the last 9 years, I believe. I'm also on Channel 9. My blog is a nice resource if you're looking for a way to go back and get started in a hands-on fashion with this. I actually just refreshed my virtual machine that I use for all of my demonstrations, and I published that as well, so you can download that virtual machine. I think I'm up to about 14 hands-on labs now that you can use to learn everything from our architecture tooling to our manual testing to coded UI tests, some of the things you'll see me do today. Worked on a couple of books. And let's get started. So, what will you need to create a coded UI test? First, you'll need either Visual Studio Premium or Ultimate, and that gives you the new test project type with the coded UI test in there. You can run a coded UI test just from the command prompt, but in order to author those, I suppose you could do them in Notepad. I wouldn't recommend it. The Visual Studio Premium and Ultimate actually give you a lot of really nice designer support to create those coded UI tests, and you'll see that today. I recommend getting Feature Pack 2. So if you have Visual Studio Premium or Ultimate with an MSDN subscription, if you go onto your subscription, you'll notice that there is a Feature Pack 1 and a Feature Pack 2. You just need to get Feature Pack 2. It actually includes all of the roll-ups from Feature Pack 1, and that includes some additional capabilities, some of which I'll be showing you here today, specifically focused around things like how do you test Firefox applications, or how do you create a coded UI test and then graphically manage that moving forward, so that you don't always have to drop into code to hand edit that. So I'll show you that today. You will need some C# or Visual Basic skills to work with these. You know, there are several test automation solutions out there, some of which focus on some scripting, some of which are just fully automated click, 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 and playback. In order to really make the most use of coded UI tests, I don't want to mislead anybody. You should really understand C# or Visual Basic. The other thing you'll need if you want to take advantage of the workflow I showed yesterday is Microsoft Test Manager for your manual testers. The idea with that is you can start with a manual test, as most tests start out, and then as your manual testers start testing that and it gets to a point that it's stabilizing and you just want to turn that into an automatic regression test, we have a pretty nice workflow I'll show you today where you can start with that manual test. Your manual testers can record all of their actions as they run that manual test, and you can use that as the basis for creating your coded UI test. And then finally, you'll need a testable application. So obviously not all applications are created equal. Our testing framework relies on us being able to get access to the accessibility layer of Windows and work with that application. Now, this is an eye chart slide, so I'll just go through it relatively quickly here. But the idea is that if you have an application at the top of this list, so if you're testing a web-based application, even if it uses AJAX commands, that's going to work very, very well. We operate at the DOM layer, so if you record in IE and then play back in Firefox, then you may see some different results there, which is a good thing, right? Because sometimes the DOM renders differently in IE versus Firefox, and we want to have tests that respect that and can actually surface those bugs. Windows Forms is supported very well. WPF is supported. SharePoint 2007 and 2010. Firefox is now supported with the Feature Pack 2. So that's Firefox 3.5 and 3.6. We need to figure out our support story for Firefox 4 now that that's released. Silverlight 4 in-browser applications are also supported within Feature Pack 2. And then as you get further down the list, your mileage may vary. So for example, Windows Win32 application, it may work, or there may be some areas where we just can't get access to the controls we need to manipulate. My advice is always just try it. You know, it's relatively easy, as you'll see today, to record a quick pass through a coded UI test and then play that back. So I would take the applications you're working with and then just throw them at our harness and see where they fall down. Chances are it'll probably just work for you just fine. And then Dynamics and MFC, you know, these mostly work. There are some nice documentation that explains some workarounds and some known limitations. And before I get too much further, let me first introduce my friend Howie from the documentation team. Howie's here all week taking your feedback on the Visual Studio documentation. So I know we made a lot of changes in the 2010 release, and they're trying to take your feedback and continue to improve the docs overall. And this, again, this will be in my slide deck, and there's links that go off to further information. So I talked about Feature Pack 2. Highly recommend that. Let's dive right into some coded UI tests. So this is, of course, Visual Studio 2010. I'm running Ultimate here. The application we're going to test with is just a very simple WPF application. So I've given presentations like this a few dozen times, and I found that really to best understand coded UI tests, it helps just to start with a very, very simple application. So this is a simple Hello World application. So we'll say Hello TechEd, and then it displays a label. So you don't really need to get any more complicated than that as you're starting to learn the basic mechanics of coded UI tests. So let's say that this is our application, and of course it's mission critical, so we want to write some coded UI tests for it. So we'll start by just creating a new project here, and it's a new testing project. How many people have worked with coded UI tests to some extent? A few of you? Okay, great. It's always good to see. Hopefully we can show you a few things that maybe you haven't uncovered. So when I create a new testing project, it's going to start just by giving me my basic unit tests, and that's just the project template. I don't need my unit test. But what I can do is just add a new testing type, and that's a coded UI test. Now, when I add a coded UI test, it's going to give me a few different options for how I want to start authoring this coded UI test. The first one I can do is I can just open up the application, have it record all of my actions as I'm typing, as I'm clicking on various buttons, as I'm resizing windows. And then it will record all those in a pseudo language and then generate code from that after I'm finished. That's one option. The other option is I can use an existing action recording. And the action recording is what comes from Microsoft Test Manager. So if you saw me record yesterday a manual test as I'm going, that's capturing what's called an action recording. It can be used in a few different ways. One is for the manual tester to actually fast forward through test cases in the future. It speeds up their testing effort, so they're not having to click 40 buttons before they get to the point that they can actually see what's going on with the application. And then the other way you can use that is this as the starting point for a coded UI test. So I'll show you both methods today, but for now we'll start with a from scratch recording. Now, before I do that, though, I just want to show you quickly the basic skeleton of this coded UI test. If you've worked with unit tests in Visual Studio before, or even in Unit, the model is actually very, very similar. So you can see I have a decoration here which says that this is a coded UI test. As I scroll down here, you can see this is the main method which actually executes all of my logic. And then, of course, I have some additional attributes down here. I can do some test initialize. I can do some test. Once the test is actually finished, I can run some cleanup logic. So if you needed to do things like insert some rows into a database, check to make sure that you can perform some operations on those rows, and then clean up that database, that's a really good chance to use test cleanup and test initialize. It's a nice place to put that kind of logic. So if you've done that before with other testing frameworks, it's going to be very, very similar. So let's go ahead and get started by just putting my cursor back within this test method. And at any time while you're creating your test, you can always click on the test menu, say generate code for coded UI test, and then use the coded UI test builder. And what you'll see down here in the corner is just a little recording icon. From left to right, I click record to actually start capturing my actions. The crosshair is what we'll use later on as we add validation to certain controls. So I can say, what is the value of this text box, or is this particular font the right color? Any number of things you can actually validate against your application. And then the button on the right is just to say I want to take the actions I've already recorded and then persist those into my coded UI test as C# or Visual Basic source code. So at this point, I'll go ahead and start recording. And from this point forward, anything that I do is going to be captured. So if your boss IMs you while you're in the middle of a coded UI test, you'll probably want to start over from scratch here. But what I can do is just open up that WPF application. You'll notice the little graphic up there that says that it's recording this particular application. So I'll say, hello, TechEd. And then I'll tab a couple times. I'll show you why that's interesting later. And click on Go and Close. So if I wanted to inspect what got captured there, I can see here. Let me pause this so that it doesn't capture my zoom here. This is actually that pseudo language I was talking about. So you can see here that we're launching the executable. We're typing hello TechEd. We hit tab a few times, and then we clicked on Go and then Close. So that looks pretty good to me. Let's go ahead and generate a method, and we'll just call it test my application, because I'm feeling particularly creative this morning. So now we can close out of the coded UI test builder, and what you see is we just generated a single method. So this is the one method that encapsulates all of the logic that I just wrote. Now, you may be wondering what's happening behind the scenes. If we go to definition, you'll see here that this looks very similar to that pseudocode list of steps that I just captured there. So there we have a comment that actually says the exact same text that it said in my pseudocode. So hello TechEd, here we're launching the project. You'll notice here that at this particular location, we actually don't have the executable stored within this particular method, and that's because all of your variables are actually stored further down in this file. So if I take a look at this window exe path, and go to definition on that, then we actually have this stored as a constant string down below. And so, or not a constant, but just a string down below. And there are a lot of places within this testing framework that we actually try to make your test more robust out of the box. And so this is just one good example of that, because what you see here is that there's actually an alternate exe path as well. And the alternate exe path is based on the recognition that that program I was running is actually nested within my Visual Studio project directory. And so we store both the absolute path and the relative path, so that if we can't find that application based on the absolute path, then we'll do a fallback to say, okay, can we find it based on some environment variable path? And so those are all things that you get for free with our testing framework. There's several such examples. Some of them depend on the types of applications that you're recording, because our coded UI test playback engine and the recording engine as well is going to depend on the type of application you're recording. So web applications are slightly different than Windows Forms applications, are slightly different than WPF applications. But for the most part, understand that we're trying our best behind the scenes to protect the robustness of your tests. A lot of people ask me, they say this is V1 technology, right? The reality is that this has actually been technology we've been using within Microsoft for the last 10 or 15 years to test Office, to test test Windows, to test all these other products. And so we've built a lot of robustness and concepts around maintainability right into this testing framework. And so you'll start to appreciate that, I think, as you start digging deeper into these tests. That's not to say that your test will never break. That's not to say that you can't make application changes which will generate false negatives. Certainly, you can always find yourself in those situations, but I'll show you some ways that you can kind of protect yourself from that just by taking that into account as you build out your tests. So that's the executable paths. If I scroll back up, there are a couple of other things worth pointing out. You'll notice that I typed all these tab keys in here. It can be tempting to just come in here and actually delete those, but I'll show you why you don't want to delete directly from this file in a moment, because this is actually a designer-generated file. So from this point forward, if you want to take advantage of the new UI map editor that we shipped in Feature Pack 2, then you really shouldn't be making changes to this file directly. The other thing here that sometimes confuses people when they first look at this is you see these XY coordinates. And people look at that and probably rightfully so, assume that this is how we're finding the controls. And that's actually what I thought when I first started digging into this framework. And so my question back to the product team was, well, wait a minute. You're telling me that if I change the size of my application, the layout of the application, the resolution of my monitor, I'm going to break all my controls? And so it really took some understanding of how this actually works. The way that we find controls within the coded UI testing framework is first based on searching and filtering. So search is a breadth-first look at your controls across your application, and we say, okay, show me all of the buttons on this particular application. And then after that, we may execute another search command that says, show me all of the buttons with this particular name. And eventually, if you're using a rich client application and you key on something like name, that's going to be unique within the given parent control that you're searching on. Now, when you get to web applications, as we know, you don't always have to assign a name to every single control on your HTML document object model. And so in that case, we apply a second level of looking for controls, which is called filtering. So we do that breadth search to say, okay, show me all of the tables on this page, and then show me all of the rows within those tables. And then we start applying filters until we narrow it down to exactly one match, and that's the control that we're looking for. Now, the XY coordinates that you see in here are used to actually tell the testing framework if I clicked in this particular area of the button when I was recording my test, then we want to try to play back the test and click as close to that area as possible in subsequent playbacks. Now, why is that interesting? Well, for this particular type of button, it's really not interesting. It doesn't matter where I click on the button. It's always going to take my text and populate that down to the label. But if you look at some controls, like down here, this is actually I believe it's called a split button control. And it makes a big difference if I click on the right arrow there and go up to log off, as opposed to clicking on the shutdown button. So in that case, we'll try to take the actual XY coordinates where I clicked within that control and use that to play back. Now, obviously, you could resize that control later on so that the point 100, 100 didn't exist anymore. And there's an algorithm where we try to get back to the origin of intent that you had when you first recorded that application. But for the most part, that will just work, and you don't have to worry about XY coordinates. And you don't also have to worry about whether or not you move controls or resize controls within your application. It should just work. Okay, speaking of just working. All right, escape wasn't working for me. Okay, now before we get too much further, I just want to make sure that this test works. So occasionally, as you're going through and making edits, it's a good idea to run the test, make sure you haven't broken anything. So here it's playing back exactly what I did. And you remember I hit tab a few times, so you saw those tabs get played back. We're going to get rid of those in a minute. Now, the other thing people ask is what delays are being used here? Are you playing it back at the same speed that you recorded it? You have that option. You also have the option of inserting your own custom delays, and I'll show you that in a minute. but by default, we actually play it back as quickly as we can. So the coded UI testing framework is actually looking at the UI thread and waiting for certain actions to complete. So if you have a data grid, and that data grid is fetching data from SQL Server, we'll wait for that operation to complete before we try to validate that the 100th row actually matches what you expect it to. Now, in some cases, you may have custom controls, or you may know that there's an asynchronous operation that's firing in the background, or every 15 seconds, and you want to wait for that to fire before you run your validation on that. And so in that case, you should be inserting custom delays. But by default, you really just don't have to worry about that. We'll play it back as quickly as we can based on when we see that the UI is actually ready for some user input. So I mentioned Feature Pack 2 gives you a graphical designer for working with your UI map files. And so if you have Feature Pack 2 installed and you double-click on this, you'll get this graphical editor. If you don't, you'll get an XML file. So good luck with that. But what I like is this graphical editor, because now what I can do is I can come in here and I can start manipulating the actions that I performed. I can start breaking them up into different methods and really start to get fine-grained control over exactly how my coded UI test works. And so one of the first things I might want to do is come in here and say, you know what, these tabs were really extraneous. Maybe I accidentally hit them while I was recording my coded UI test. In the future, I really don't want to play those tabs because they may have an effect on my application. Maybe as you're changing focus from control to control, that's firing some logic, and that's not really the origin of intent. That's not what you want to test. And so in this case, what I can do is I can just drop into each one of these tabs and delete them. And what this is doing is it's actually removing it from that test method that I showed you earlier. So we'll go ahead and save that. Now, the other thing that I might do is, I mentioned delays. I can insert a delay in here just by inserting a delay like that, and then I can specify, how many seconds I want it to wait. In this case, I don't need a delay, so I'll delete that. And the other thing I can do is actually split this into multiple methods. So maybe I want to change this so that I have a launch method, so launch my application, and then I have a worker method where I'm doing some manipulation with the application, and potentially maybe I want to do this 100 times where I type something in the text box and I click go, type something else in the text box, click go. So I could just wrap that in its own method, put that into a for loop, and then at the very end come back and close that application. So to do something like that, you would just say split into method. It's telling me that I need to manually go back and update my coded UI test harness to call that method, so I'm okay with that. So we'll split this into 3 methods, and then we'll just rename these launch application, test stuff. Like I said, very creative this morning, and close application. The other thing to point out here is that these are listed in alphabetical order, so that sometimes trips people up as well. So the order in which I call these is actually dictated by that coded UI test harness, so we'll go back and update that momentarily. But within the UI map file, we have no knowledge of which order you're calling these in, so we actually just list these in alphabetical order. So we'll come back to that momentarily, but I just want to make sure that I update my coded UI test file. Okay. Over on the right-hand side, this is what we call our control map. So as you're manipulating your application, we're actually capturing the controls that are relevant that we'll need to play back. And this is where we capture some understanding of that control. So for example, those search and filter properties get stored as part of this UI control map. And so if I look, for example, at this Go button and look at the properties down here, you'll notice that I have this search configuration and these search properties. If I look at the search properties, this is the list of breadth search steps that we run through, and we run through them in this order. So first, when we look across this rich client application, we're going to look for anything that's a button, and it's equal to this particular UI accessibility framework. You can ignore that line. And then we're going to look for something that's named My Button. And again, because this is a rich client application and the control names have to be unique, this is very, very easy for us to find this button, and we can stop there. We know that there's only going to be one button, or the application is broken, or a developer has changed the name of that button, and so maybe we're generating a false negative there. But at the end of the day, that's all we need. Now, when you generate a web application, you'll also have that list of filter steps as well, and those get applied from top to bottom. And so if we ran across a web application and we found 5 controls after this search that matched our configuration, then we would run the first filter step. If that brought us down to 1 control, then we know that's the control we're looking for. If it brought us down to 0 controls, the test is going to fail. If it brought us down to 3 controls, then we would then apply the next filter command, and hopefully that would bring us down to 1 control after that, so that's the control we're looking for. So most of the time you don't need to worry about this. However, if you use frameworks which dynamically generate control names within your applications, or if your web application framework doesn't generate any control names at all, then you'll want to really take a look at these filter properties, because by structuring them in the right order, moving them up and down, or just using some things that you know may be unique about a given set of controls, that can really help improve the accuracy of our testing playback. So we'll leave that the way it is for now. The other thing that you can do on a step is you can say whether or not we can continue if it fails. So on this particular step, let me make that bigger. We can say continue on error. By default, continue on error is false, which means that any time a particular step fails, we're going to fail the entire test. Most of the time, that's probably what you want. However, there are some cases where occasionally you may have an event that only happens once in a while. I know that every time I go to MSDN, it feels like I'm always picked to fill out some survey, right? I'm sure that doesn't happen to anyone else, right? But occasionally, these things can pop up sporadically, and we want our test to gracefully respond to that. So another good example is, if you're using Internet Explorer on a clean machine and you start filling out a form and you press submit, then that very first time you do that, it's going to say, hey, do you want Internet Explorer to remember your form settings for the next time we fill out this particular form? And you can say no on the particular machine you're writing the test on, but unless you explicitly go to all of the machines within your test environment and make sure that you turn off that setting, then that can actually cause your test to fail. So what you should do is you should say no when you're first recording that test, and then when you deploy it out to your test environment, make sure that you've set the continue on error equals to true, so that if we don't find that pop-up, then we can still continue to the next step. It just means we haven't received that particular request. Okay? Now it's early in the morning. I'm paranoid. Let's just run this test again and make sure that it works okay. Great. Okay. So at this point, we're testing the application, but just barely. I mean, the only way that we would generate a test failure here is if we removed one of those buttons, or if the logic changed so that when we did something, it popped a different dialog, and we didn't know how to respond to that dialog. We're not actually replacing the manual tester who's looking at this and saying, yes, this looks right, or no, this is formatted incorrectly. So let's start by adding some assertion logic here. What I can do is just place my cursor at the place within this test harness that we want to run some assertion logic. So after I type some text in the text box and then press enter, we want to validate what that label looks like. So what I'll do is I'll just say test, generate code for new test, use coded UI test builder. Again, you can always drop back into this coded UI test builder to add new actions or to add validation logic. And so if I just drop into here, actually, let me show you a trick for getting the application back into the state that you might want to validate it on. Let me close out of there. If I just comment out, closing the application, and then run the test, then it will take it right back to the same place that it was at, which for this simple application isn't saving me a lot of work, but you can imagine for a more complex application might be kind of interesting here. So now if I say generate code, then I can take this crosshair, I can drop it onto my label down here, And I'm going to get a property bag that tells me all the different property values that are on that particular control. And so in this case, I just want to validate against display text. So we'll add an assertion on display text, but we could add assertions on anything we wanted. Is the control visible? Is the font equal to such and such? So there's a lot of different things that you may choose to validate on there, and you can add as many of those as you want to your test. So we'll just add a quick assertion here, make sure that it's equal to hello TechEd, and we'll generate that code, validate label. So now once again, run our test, make sure that still works. Now I think it's working, but let's actually cause this test to fail to make sure that it's working. Now, one way I could do that is I could drop into the actual values that we're passing into the text box and change that from within the UI map. But the other thing that I can do is actually change that right within the code as well. And to do that, what I do is just say this.uimap.testStuffParams. So this is the other class that's stored within that file, which stores all of my parameters. And then I pass it in the name of the control that I want to override. And then we'll say goodbye, TechEd. So now when I run this, before it actually tests stuff, it's going to override that parameter, and now that test is failing. And of course, that test is failing because when we get down here, it's saying that hello TechEd and goodbye TechEd don't match. So that's what we expect, and that's interesting, and that's something that we can actually file as a bug. Now, one of the things you may have noticed down here is that when I did that, when the test failed, it actually left my WPF application running down here because we never got to the close. It actually hit the test failure, and then it abandoned out of the method, and so it never actually disposed of that particular object. And on this particular environment, that's okay. It's a tiny application, but if you deploy this into a test lab and you're running hundreds or thousands of tests overnight, then that could be a problem. You may have applications that don't like being started in multiple instances as well, and so you need to make sure that you're always shutting down those applications. Now, there's a few different ways to do this. One way is to wrap your logic in a try-catch. Another way is to make sure that in the test cleanup method, you're just closing all of the applications that you use. And another way is to take advantage of the using clause. I like the using clause, and so we'll do that here. The idea with using, if you haven't used that before, is that as soon as the object you're using goes out of scope, it will automatically be disposed. And so in order to take advantage of that, what I can do is just copy where we're launching the application. And so I dropped into that launch application page. Actually, I didn't copy that right, sorry. So I'm just pulling forward the name of the application that we're launching, and we need to just forward reference that to be in the UI map file. So at this point, we actually no longer need our launch application method, and we no longer need our close application method. However, don't delete those methods. So the reason for that is if you go into the UI map file and you now delete either one of those methods, it's also going to delete the parameters for launching the application as well, because the designer thinks, okay, you're done with that particular method, so you can be done with those parameters as well. So all I would suggest is just extract that manually, but keep those methods around. So now if we run our test, it should launch it. Oh, what did I miss here? It should launch it, and as soon as that particular object goes out of scope, so when the test fails in this case, it's automatically going to close it. So if you see at the bottom, we no longer have our WPF application down there. So that's nice. Now, the other thing that I could do is I could now data bind this test. So if you've data bound unit tests before, the framework, the way that you can data bind coded UI test is exactly the same. So rather than just write 100 tests for each different type of variable and configuration that I might want to test with, let's data bind this particular test. The way that you do that is you just click on Test, Windows, and then Test View. And this gives you access to all the tests within your project. And then there's a property down here called data connection string. And if you click the ellipse on this, you'll get a really nice wizard that allows you to point this at a database, at an XML file, at a CSV file. And so I have a CSV file that just has a few different parameters that I might want to test with. If I preview this, you'll see what it looks like. Here you can see we just have a simple labeled columns, input, output, and then a few different strings that we want to pass in. In fact, there it's giving us a preview. And then it's going to ask us if we want to add this to our project, and I suggest doing that because then you can take your parameters and you can version control them right along with your test. So we'll add that as a deployment item. It's just going to add it to our project. And now what I can say is that instead of passing in goodbye TechEd, we'll just say test context data row, pass in the name of the column, and toString. And then when we validate, we want to say the same thing. So this.UIMap.validate expected values, and then the name of the value we're looking for equals test context data row output toString. Okay. So now when I run this test, the other thing to point out up here is when I did that, it actually decorated this particular method with the data binding information. So here you can see that we're binding to a CSV file, so that's the data adapter. There's the directory where the CSV file exists. We're going through sequentially. We could change that to random if we wanted to. And then that's a deployment item that's in my project. So now if I run this test again, it should run once for every row that's within that particular CSV file. So if I went out and I updated that CSV file later on, made changes, redeployed that, maybe there's a particular string I want to capture, maybe I want to test with Unicode characters to make sure that that shows up properly, then I could test that and just update that moving forward. So if you saw that run pretty quickly and everything passed, however, those of you in the front may have noticed that we had some formatting issues. So that label didn't quite look right. So what I could do is I could go back to this test and I could add all sorts of additional assertion logic to say, if the text in this particular label is actually longer based on the font size than the length of the label, and yada, 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 yada. And I could do that for every control and come up with some really fancy logic to say programmatically whether or not this looks like what we expect it to look like. That's certainly an option, and you could be coding all weekend and make that baked into your test. But sometimes I think there's just no substitute for having a human being look at the results of your tests and make sure that they look correctly. And so one of the things you can do with our framework is as you're moving through your tests, you can actually just take snapshots as you go. And you can save those snapshots to the test results. I've seen some people take those snapshots and save them to a Word document so that a tester can come in the morning and quickly just scan through a document and say, yes, all of this workflow looks correct, or no, there's a problem over here. So let's do that here. If we just create a new image. Whoops, sorry. I want my application window as the top here. So now we're going to capture that image at this point in time. And then the last thing I need to do is actually just save that to my test result. The other thing you can do is you can actually capture the entire desktop if that's interesting as well, and I'll show you the code for that in a minute. Okay, so there's my test run. And here you can see that I have 3 files. You might want to give them more interesting names, like maybe I would want to name these files based on the actual string I was passing in. But here you can see that hello world, that looks pretty good, so I'm going to sign off on that particular test. But then if I get to some of these others, you'll notice that it's actually getting truncated. So the quick brown fox, yada, 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 it's getting cut off. So I might file this as a bug. This is something that I want to report back to my development team. And so one way you can do that is you can go straight from the test result, and you can say, is that the button? I never remember which ones they are. I always have to mouse over them. Yeah, so you want to publish your test results, and that's going to publish them back to Team Foundation Server. And then what you can do is you can create a bug from there. And so once I create that bug, it's automatically going to include those attachments. And so those are the files that I'm attaching. And so maybe the first one looked okay, so I can go ahead and delete that. But the others I want to include as an attachment so that the tester or the developer understands exactly what's going on with that particular bug. Okay. So those are a few quick examples. I'll show you just quickly through some slides here some of the other things that we won't have time to get to, but are some interesting things for you to explore on your own. So a few of these we already covered. These are just notes for you so that you can go back and remember how to do them when you're writing coded UI tests on your own. So get used to using, it's useful. And of course, the other way you can do this is to use the cleanup method or to just wrap some of the logic you're doing in a try-catch so that you finally are closing the application when you're done. And then this is just some more information on how we search for those controls, how you filter the controls. There's an excellent blog post if you click on, if you follow these links, so tinyurl.com/search and filter will take you to more information on how the testing framework actually finds those controls. And again, that's something that I recommend you spend some time getting used to so that you can make sure that you're building and maintaining your applications in such a way that you don't generate false positives within your coded UI test. So that's something that is worth understanding. And then, of course, understanding the XY coordinates is always something that I see trip people up. Data binding, so there's a couple of different ways to data bind. I like going through the test window and just mapping that. And then when you record this using a manual test and you elevate a manual test that may have test parameters, as I'll do here in a few minutes, it actually automatically data binds that. And because the test case from the manual testing client is actually stored within Team Foundation Server, you don't need to have a separate repository for storing those parameters. Everything just gets persisted right with the test case, which then gets stored within Team Foundation Server. And I'll show that to you in a minute. Assertions, you can sometimes actually help your testers by going in and adding smarter assertions. So rather than just say, these values didn't match, you can give some more information like, hey, the sales tax total is wrong. And so that's something that I recommend that you do if you're adding a lot of assertions, especially if you have multiple assertions within a file and you don't know necessarily which one's causing the failure. You can actually make your assertions a little bit smarter so that your testers have an easier time of diagnosing and triaging the bugs that are coming off of the failed test runs. Here's the information for capturing the images, and if you wanted to capture the entire desktop, that's the code for it. So it's UI test control.desktop.captureImage. And then let's talk about moving tests from Microsoft Test Manager into a coded UI test. There are some things that are straightforward about it, but there are some things that I recommend as best practices that can help you make better tests based on the way that you record your test within Microsoft Test Manager. So how many people were in my session yesterday? Okay, great. So a little bit of this is going to be a repeat for you. I apologize. But for those of you that haven't seen it, Microsoft Test Manager is the new client within Visual Studio 2010. It was built from the ground up for manual testers. So you can come in here and you can author your test plans, you can author your test cases, and you can go through and run those test cases. And when you find a bug, you can capture rich, actionable data to file back to the developer. So you're not just getting a one-line description of, hey, this failed, but you're actually getting things like video recordings and stack traces from the IntelliTrace files and event log information and system information. So let's say that I have a test case in here that's passing on a regular basis, and I want to create a coded UI test from that. So here I have one that says entering invalid data on the shopping cart should not cause the cart to, to change the value. So like if I type -1, we don't want to pay our customers to shop from us. That would be a losing business model. So if I run this test as a manual tester, one of the things that I can do when I'm running this test is I can create those action recordings I was talking about earlier. So there's already an action recording with this particular test case. I'll just overwrite it, which is something you may do occasionally as the application is changing from time to time. So we'll go ahead and start that test. And now from this point forward, anything that I do is going to be captured as part of that action recording, with the exception of interacting with the test client itself. And it can be tempting to just run through these test cases and just not mark each test step as pass-fail. And normally when you're running through your test cases, that's just fine. But when you're creating action recordings, as I showed yesterday, I definitely recommend coming in here and marking each step as pass-fail. And the reason for that is that your actions for each step are then going to be associated with that individual step, so that when you create those coded UI tests, you'll get a much cleaner set of code by doing that. And so now at this point, it's telling me to change the quantity to the letter A. So we'll do that. We'll paste that in there. And it automatically filled my clipboard buffer with the quantity it wanted from that data binding. And so now if I click on the white space somewhere, it's telling me that this should revert back to 1. And sure enough, it does. So I'm going to pass that. And then I'm just going to clean up my test case here. And close the browser. Now I can end this iteration. It's asking me if I want to overwrite the action recording, which yes, I do, because I'm going to turn this into a coded UI test. And I could run the rest of these tests manually. I'm not going to. I don't need to at this point. Instead, I'm going to drop back into Visual Studio, and we'll create a new test project. Again, I'm just going to get rid of that unit test. I don't need it. And now, instead of recording this from scratch, I'm going to say that I want to use an existing action recording. And so this is going to open up the work item picker. And so I could query against Team Foundation Server. One of the things that you can do with your work items here, since a test case is really a work item, it has a workflow just like a bug test case does, or a user story work item does, rather. And so one of the fields you can choose is to set the automation status to planned. And so your manual testers may say, okay, this particular test case, it's passing on a regular basis. We would like the development team to create an automated test out of it. And so they can drop into that test case and change the automation status field to planned. And then you can drop into here on a regular basis and query for anything that's set to planned. And then once you have automated it, you can actually switch it one more time to automated. And that way it makes it really easy for you to query against all of your test cases and say, show me the automated ones, show me the manual ones, and show me the ones that we still need to invest in creating automated test cases from. In this case, I just happen to know that that's test case number 41, so we'll just point at that directly. And now this is going to take that action recording and, in this case, turn it into C# code. Of course, if I was writing in Visual Basic, it would turn it into Visual Basic code. And then again, if I look at go-to definition here, you'll notice down here that we have the same type of system in place. So this is where we're launching the application based on the web page address. The other thing I can show you now that we're using a web application is I can show you those filter properties. So if I look at this edit box down here, you'll notice that we have filter properties. And this, again, is the list of commands that we run sequentially until we find exactly one match within the set of controls that we searched for. So in the interest of time, since we started late, I'm not going to add any assertion logic, but I will just run this. And I'll point out before I do that, again, we're taking advantage of data binding here. So it's now pointing straight to the Team Foundation Server project and that particular work item, and it's going to run sequentially through that set of test parameters. So if I drop back into that test case and show you that test case, the parameters that we're getting come straight from the parameter values that are stored down here. So if I added a new parameter value, then reran the test case, it would just run with that new parameter value. So it makes it really easy. And what I like about that model is that your manual testers, even if they don't use Visual Studio, they don't check code into source control, maybe they don't have access to the databases that you're using to parameterize your other test cases, they can still get access to the manual test case, and they can come back here and add new parameter values. So I'll just go ahead and run this and show how that works there. So again, it's playing back using those search and filter properties. And if we were to make this a real test case, if we had time, we would just add some assertion that says that this particular text box is equal to 1 after we refresh that page. Okay. So a few more tips and additional follow-up information. So this is what I was mentioning earlier. So if you want to do conditional steps where, if we don't pass this step, we can still keep going. That's a good example. Do you want Internet Explorer to remember this password? You'll say no or yes on your developer workstation, but you can't always guarantee that the test configurations are going to be the same way within your test environment. If you want to record an IE, you can now play back in Firefox using Feature Pack 2. The way you do that is just at the beginning of your test case, or the beginning of your test harness, you set the browser window to Firefox. Now, there's one interesting thing that happens when you're playing back a test case multiple times within Firefox. If you were to do that just by using the same methods that we showed here today, Firefox would actually not close down in time, so that when you start the next test case iteration, it will tell you that there's already an instance of Firefox running. That just has to do with a timing issue and the way that we get the information back from Internet Explorer, but we don't get that back by default with Firefox. So if you find yourself doing that, then instead switch your close logic to this.uimap, and then the browser window control that you're using .close. And that's actually a better method, which waits for a callback to say, yes, the Firefox browser is closed before it tries to move on to the next test case iteration. Multiple UI maps are something that I won't be showing you today, but it is something that for some of your applications, you may want to use multiple UI maps to break apart the logic that you're recording. So a good example might be, I have a composite control that gets used in a lot of different applications, and rather than record that composite control logic and all of the controls and all the information that explains how to interact with that particular control, rather than record that across every test case within my suite of coded UI tests, I might just want to record that once and store the information in one UI map file, and then reference that UI map file from my other locations. So that gives us the best of both worlds, where we can have multiple people working on the file, and we can also maintain that in a single location. If you find yourself getting interested in that, one of our team members wrote a blog post and has a sample file you can download which explains how to do that. It's pretty straightforward. You basically right-click and say add a new UI map file to your project, and then as you start recording information into that UI map file, you go back to your test harness and you reference that UI map file instead of the main one that you're working on. Making your applications more testable, of course, is something that you may be thinking about as you see how this UI testing framework works. What I always recommend, of course, is that if you're building web applications, think about giving names to your controls. That, of course, is going to mean that we don't have to rely as much on those filter properties, and instead we can go specifically to that unique name within the document object model. The other thing, of course, is to educate your developers who are building applications who may not be writing coded UI tests about how the coded UI testing framework works. And so one thing you may want to point out to them, of course, is that once you pick a control name, you should try to stick with that control name. Whether you prefer Hungarian notation or camel casing or whatever you want to use there, stick with that name because that's going to make it easier for you to maintain your test suite over time. And of course, you should remind them that they can move the controls around, they can resize them, they can do lots of stuff within that flexible framework. But for the most part, unless they have a really good reason for changing those control names, stick with the ones that you're using. And if you do have to change those control names, refactor everything together as part of one refactoring operation if you can. And then, of course, educate your manual testers on what makes a good coded UI test. That doesn't mean you need to teach them C# and Visual Basic, but it does mean that as you're showing them how to run those manual tests to get them ready with an action recording that you'll build your coded UI test from, you may want to point out to them that, hey, if you mark each test step as pass or fail, that's going to give us cleaner code when we build the coded UI test. A lot of people ask about whether or not you can use this with load testing. So if you've used our load testing framework in the past, you know that you can create a load test and you can throw other test types at it. The most common is going to be a web performance test. So I might record a path through my application where the user is creating a new account, another one where the user is shopping for an item, and then a third one where the user is checking out. And then I might want to model a load matrix where 10% of my users are creating new accounts, 80% are shopping, and 10% are checking out. And then you can get a lot of really interesting analytics out of that to say, how does this scale for 50 users, for 500 users, for 5,000 users? That works really, really well with web tests because we actually operate against the HTTP, HTTPS layer. The challenge with doing the same with coded UI tests is a coded UI test assumes that it's sitting in front of your mouse and keyboard. So in order to simulate 10 users hitting your site by running 10 different coded UI tests, you need to have 10 different physical or virtual machines. So it's possible to do that. This blog post or this MSDN article will actually explain how to do that, but just take that into consideration that if you want to use coded UI tests to drive load, you will need to think about how to scale that up with some number of virtual or physical machines. Playback settings, some of this stuff in here you probably won't hit. Playback settings basically decide, how aggressive we are, for example, when we're working on that playback engine. So as I mentioned earlier, we're going to try to drive the control as soon as that control is available. And sometimes you can insert delays to say, hey, I know that every 15 seconds we're updating this application. And there's also some other tweaks you can do within those playback settings as well. If you're using an older operating system, so something prior to Windows 7 on the client side or prior to Windows Server 2008 R2 on the server side, make sure to get this platform update. This will actually update the accessibility layer within Windows, and that makes it easier to not only record your applications, but also play them back. We actually just get richer information about the controls we're working on. And again, all this is in my slide deck, so you don't have to frantically write down those addresses. Now, as you start to scale out these applications, you can start to take advantage of our scalable testing framework. And we have what we call test controllers and test agents. So let me just quickly show you that framework. This is also on my blog. And you'll notice in this diagram, Team Foundation Server is at the heart of everything. However, Team Foundation Server is not explicitly required if you're doing coded UI tests. It is required if you're doing manual testing with Microsoft Test Manager, but if you're doing test automation, you don't actually need that. The test controllers are responsible for orchestrating the tests that are going to be executed against one or more physical or virtual machines. And then on those physical virtual machines, you'll install what are called test agents. And those test agents are responsible for executing the tests, and they're also responsible for reporting back the results. If you saw yesterday when I modified the test settings to say what information we wanted to collect off of each role within my environment, so I want to capture a video recording over here, an IntelliTrace file over here, an event log over here, the test agent is also responsible for packaging up that information on a per machine basis and publishing that back as part of the test results to the test controller. So I'm not going to get into the specifics of setting up test controllers and test agents, but if you find yourself interested in this, there's some pretty good documentation now that explains which ports you need open. You know, if you have different environments where you have your test environment in one domain and your Team Foundation server in a different domain, there's some documentation that explains exactly how to set up those types of environments. So in the time remaining, I want to show you actually our lab management infrastructure. Anybody out there playing with lab management today? Just a few of you. Okay, great. So, so the rest of you may not have seen what we did with respect to lab management. The idea here is that we want to make it really easy for you to set up even complex build, deploy, test workflows. So the idea is that maybe every night or even maybe multiple times per day, I want to build my code, you know, compile it, generate an MSI file, generate a SQL script, whatever is the output of my particular project. And then I want to deploy that to one or more environments. Most of the time we're working with virtual environments, although you can set up most of this with physical environments as well. And so what we do with our lab management infrastructure is allow you to specify a virtual environment with one or more virtual machines. So in this case, I just have a virtual environment that consists of a web server and a database server. And so I can spin those up to some known state. So maybe it's, you know, a state with everything installed from Microsoft, so Windows and SQL Server, but I haven't yet deployed my application to these machines, right? So I snapshot that into some known state, and then when I start off this workflow, I'm going to restore that to that clean state. And then once everything is restored, I can then take the MSI files and run those on the application tier. I can take the SQL scripts and run those on the database tier so that I'm actually installing my application. Optionally, I can then snapshot that environment again so that before I run my tests, I have, you know, this is Friday night's build installed in this particular virtual environment. And then once that's ready, I can begin running my tests. If anything needs to be run manually, my manual testers can connect to those environments and run those tests manually, just like they would within your test labs today, but they don't have to waste their time installing the daily builds. They can just connect to that right away. And if you find a bug, what's really cool about this, if you're using virtual environments, is you can actually snapshot the entire virtual environment so that if I find a bug in Howie's code and I file that to him, you know, what happens today? Howie says, wait, don't touch a thing. You know, give me a second to get over there and take a look at exactly what's going on. So now as a tester, you know, I'm twiddling my thumbs waiting for Howie to come look at my machines. But if I'm able to snapshot that entire environment, then Howie can take a look at it when he has the time. I can keep working with the testing environment, running the other tests I need to run, and then once he's ready, he can reinflate that to the known state that I found that bug in, and he can see an environment that repros that bug that I found, and he should be able to get everything that he needs. So what I'd like to do is actually, in the time we have remaining, I just want to show you my lab management environment. So this is my lab management environment. This is Microsoft Test Manager connected to my environment. I apologize for the resolution. You can see most of that there. And what you see here is that I have a virtual environment that's running over here. I can double-click on this image, and it's effectively going to open up an RDP session into that particular virtual environment. And I'll be able to take a look at each one of these machines. So I have a web server, and I have a client machine. I think it went to sleep over here. Just give it a second. While we're waiting for that to wake up, I want to make a code change and deploy and test that within my environment. And to prove to you that this is real, I think you said that you're using lab management, right? So I'm going to pick on you here. Give me the name of your favorite dessert. Chocolate ice cream. I like that, even at 9:30 a.m. That sounds delicious. So what we'll do is we'll actually just change something on our application. We'll save that, and I'll just check that in. Okay, so now that's part of my Team Foundation Server source code repository, and we want to actually build and deploy that as part of this environment. So here you can see my environment came up. These are each one of the machines. There's my IIS server. This is my web client, or my web server rather. If we take a look at the snapshots over here, you can see what I was talking about in terms of having a clean state. So if I rolled back to a clean state, that would be before I've actually deployed my application. And actually before you came in this morning, I actually manually rolled back to the clean state. So we've already taken care of that step. And then you can see all these nightly builds down here. So if I wanted to, at any point in time, jump to last Thursday night's build, I could just click on that, say restore, and 30 seconds later, I'd be able to see my software running on Thursday night's build. But we want to deploy our chocolate ice cream changes down here. And so what I can do is just right-click on my build definition. We're taking advantage of Team Build here for all the workflow. And we'll say Queue New Build. Now, while that's starting to spin up, I'll jump into the build definition and show you exactly what's going on here. So the build, if you've used Team Foundation Server build, it looks like any other build definition. I could decide that I wanted this to be a continuous integration build, so every check-in would trigger this workflow. There's scheduling that I can do. Here it's just a manual build for now. And then I can drop down to the Process tab, and this is really where the magic happens. So if I look at the details on this particular build, I'm specifying the environment. So within Microsoft Test Manager, I defined a virtual environment, which was a multi-machine environment. I maybe could have defined a different one, which was running a different flavor of SQL, a different flavor of Windows if I wanted to. And then I can optionally restore back to some clean state. In the interest of time, I've done that already, so I'm not doing that automatically. I did that manually. And then we can decide whether or not to generate a new build to actually create those MSI files or whatever the output of my project was. So in this case, I'm creating a new build based on our chocolate ice cream. And then after that, we then deploy that build. And this is basically, it's pretty straightforward, but basically this is just a list of the commands we want to execute in which order on each one of those machines. And you can use some variables like build location, where are we getting the builds from, pass in the machine name, pass in the domain name. So there's a few different variables that are documented that explain how to actually customize this within that environment so that you're taking advantage of the machine-specific information. The other thing that we have within our architecture here is network fencing as well. So if I wanted to create 10 different virtual machines and have all of them have the same name and IP address, I could do that without a problem. We can install what are called lab agents on those machines. And then when we connect and run all of our tests and all of our RDP sessions, we're actually tunneling through those lab agents as opposed to relying on the machine name. So it gives you a really nice option there. And in fact, you could even use that to simulate the exact same machine names and IP addresses that are in your production environment. So that gives you a lot of flexibility there. After that, I could take a snapshot of that before I've run any tests. And then this is where I'm running my tests. So here I'm pointing it at my test plan. And so this test plan was generated using Microsoft Test Manager, and I added any test to it that I wanted to run, and I associated automation with those tests. So what I mean by associated automation is that I created a coded UI test or a unit test or some DLL. I checked that into Team Foundation Server, and then I said that for this test case, when you execute this test plan, I want you to run this particular DLL. Now let's check back in with our environment. Looks like we're still deploying here, so this should come up momentarily. In fact, we could monitor the progress of our build. So you can see that it actually kicked off a new compile build over here as well. And so that's what compiled our project. And then if we take a look at the overall build, this is where it's at. It's waiting for the workflow capability to be ready. and it looks like it is ready. So any moment now, it should actually take that test. We have a coded UI test that we're going to run, and it's going to deploy into this particular environment. And I know you can't see this, but down here at the bottom it says test progress 0 of 0. This is our test agent that's running on the machine in an interactive mode. And once that test is actually ready, it'll push it down to that environment. It should run here in just a minute. While we're waiting for it to push down, remember I'm running 4 different virtual machines on this laptop, so your results will be much better in your test environment. Does anybody have any questions? Yeah. Is there a way to set a global condition? So if I ever display a modal dialog, fail the test completely. I can't think of a quick way to do that. I would say, you know, if you display a modal dialog, why are you testing that? You want to make sure your developers aren't using modal dialogs? I see. Oh, that's interesting. So he has some user experience guidelines, and he wants to make sure his developers aren't using modal dialogues. That's an interesting one. What I would say is write that in as an assertion to make sure that you're inspecting this control isn't modal, but then you will have to manually insert that every time, so you'll have to call that assertion. So I can't think of a good way to say, you know, throughout the history of this test run, make sure we never see a modal dialog. It doesn't quite work that way. Yeah. Yeah. Just tap it a few times. Reboot? No? That's a great question. Oh, our tests are starting up now. That's a great question. So the question was, are all these VMs running in Hyper-V? And the answer is that yes, everything that our lab management infrastructure depends on for this setup is going to be running within Hyper-V. Now, with that said, Howie has some documentation in the MSDN library that explains what you can get with VMware and what you can get with physical machines as well. Basically, with those types of environments, you can't take advantage of the snapshotting. So if you wanted to use some other process, I've seen people go in and actually script the VMware commands, but that's not supported out of the box with our framework. So it's something that you can make work, and it's something that we're working towards in future releases. But for now, if you can use Hyper-V, that'll give you the richest experience. Yeah. Yeah, I think there's one back there. Sorry.
Oh, it works. How much of this is available automatically in Visual Studio, and how much of it do we have to, you know, buy or download or get?
That's a great question. So yes, so Team Foundation Server includes the lab management capability. So you can actually take Team Foundation Server, you can enable lab management, and we give you the development and test rights to SCVMM, System Center Virtual Machine Manager, which we use under the covers to spin up the environments and to start all those workflows. Now, in order for your users to actually connect to those environments, they'll need to have Microsoft Test Manager. 2 ways to get that are, one is you can buy just Test Professional as a standalone SKU, or you can buy Visual Studio Ultimate, which of course comes with everything. Yeah, great question. You can see here, actually, just to point out that at the bottom, we have our chocolate ice cream. So you can see that this isn't smoke and mirrors, that we actually passed that in. So here we ran our tests, and we reported the test results. And if we take a look at that agent, you can see that the agent's basically gone back to sleep here. Is there a question there?
Just a comment. It seems like with the modal dialog box, coming at it from the other side with code validation, possibly gated check-ins, could go at it from that side.
Yeah, I like that idea. So he's saying use something like static analysis, write a rule to say if you're ever using modal. And then if you haven't seen gated check-ins in the new release, gated check-ins basically make sure that when your developers check in code, that we're actually running some sort of validation and making sure that the build passes prior to committing it to your source control. So you never break the build again. You never have to buy pizza and beer for your team. So it's a nice feature. Yeah, thank you. Yep. You can just start talking. It's OK.
So do we need TFS 2010, or could we run it on TFS 2008?
Yes, you
If we
will
have-
need Team Foundation Server 2010 to take advantage of the lab management workflows.
Okay.
If you want to just use coded UI test that I showed in the first half, then you don't even need any source control for that.
Okay, just Ultimate, 2010 Ultimate, right?
Visual Studio, to write coded UI tests, you need Visual Studio 2010 Premium or Ultimate.
Or-
And then the other thing that a lot of people actually don't realize is that with 2010, if you have an MSDN subscription, we already give you a license to Team Foundation Server, so you already own lab management, and you can start setting that up.
What do we need to do that?
What do you need to set up Team Foundation Server and lab management?
Yeah, we have TFS 2008.
Okay.
Not 10. Yeah.
So if you want to take advantage of lab management, you'll need to upgrade to 2010. If you have some time this week, come by the booth in the exhibition hall. We've got some guys from the TFS team, and we can give you some pointers in terms of upgrading.
Okay, anytime during the day, right?
Anytime there, I don't know exactly when the expo hall is open, but anytime the expo hall is open, we have a TFS booth. Yeah, thank you. Yeah.
Yesterday you showed the test impact analysis on the test manager.
Yeah.
Is it possible for, after the build, only run those recommended tests, the ones that we know cover the changes that were done?
Yes, so he's talking about test impact analysis, where we're actually taking a look at the code that you're running and making an association between the tests that are relying on those methods of the code. And yes, you can do that. You can say only run the impacted tests. For an automated environment, if you're running it overnight, I would recommend just running all of the tests. But yes, if you're doing like a continuous integration environment where you need to run it multiple times a day, then you can certainly take advantage of that. I see that I'm over time, so I want to thank you for coming.